Hey there, welcome to day 17. I hope it goes better than day 16 because day 16 did not go well, but maybe day 17 will go well. So let's try this thing. Spinlock. Suddenly whirling in the distance, you notice what looks like a massive pixelated hurricane, a deadly spinlock. The spinlock isn't just consuming computing power, but memory too, blah, blah, blah. So that printer algorithm is simple but efficient, quickly consuming everything in its path. It starts with a circular buffer containing only the value 0, which marks the current position. Then steps forward through the circular buffer some number of steps, your puzzle input, before inserting the first value 1 after the value it stopped on. Inserted value becomes the current position. Then it steps forward from there the same number of steps wherever it stops and inserts after it the second new value 2. Uses that. Repeats this process of stepping forward, inserting a new value, using the location of the inserted values in the new current position a total of 2017 times, starting 2017, ending with a total of 2018 values in the circular buffer. Okay, so I don't understand this at all, so let's look at their example. For example, if Spinlock were to step 3 times for insert, circular buffer would begin to evolve like this. Okay, so 0 is the initial state, 0, 1, the Spinlock steps forward 3 times, 0, 0, 0, and insert the first value after it. Song steps forward 3 times, 0, 1, 0, insert the second value, then it steps forward 3 times, 1, 0, 2, and then inserts the third value after it. 3 becomes the current position, and so on. Eventually, after 2017 insertions, the section of the circular buffer near the last insertion looks like this. Perhaps if you can identify the value that will ultimately be after the last value written, you can short circuit the Spinlock. This example, that would be 638. So it's basically saying that I think I understand this, but it's possible I don't. So let's just try solving their problem. Day 17 spinlock.py. And my concern that I'm thinking about right now is that inserting things in the middle of a list is expensive. But I'm just going to not worry about that now because I think we'll be okay with 2017 times. And then in part 2 they'll screw us and we'll have to rewrite it, but that's fine. So I want to Spinlock, and let's say step size, which is an int, and num spins, which is also an int, and it is going to return. Let's do from typing import named tuple, and let's just say let's call circular buffer is a named tuple, and what is it going to have? It is going to have a buffer, which is a list of ints, and that just equals 0, and it's going to have so let's see, containing only the value 0. List int equals, actually I can't do this, because basically you can't use lists as default values, so I'm going to have to use do the following. Self.buffer equals that 0 and self.position equals 0. So that's fine. And it is going to return now a circular buffer. Okay, and so let's just say CB equals circular buffer. And now now that I've done this, I can just add these methods up here, which will be fine. So let's say def step forward self, and that's going to do none. And so what do I want to do? N equals len of self dot buffer, and self dot pause equals self dot pause plus self dot let me do num steps, which is a step forward. I'll call it step size. So int self pause plus step size, and then mod by n. And now I'm worried about an off by one error here, so, but I'll deal with that in a minute. And then I want to def insert self and value, which is an int, and that's going to be a none. And now if I have a position, I want to insert it after it, right? So I want to do self.buffer equals self.buffer up to and including pause, right? So if it's at 0, I'm going to include up to 0 plus value plus self.buffer pause plus 1 to the end. Okay. So, and this is too long, so let me split it across multiple lines. Plus value plus self.buffer self.pause plus 1, and then do I need to do something in the position as well? The inserted value becomes the current position. So then I also need to do self.pause plus equals 1. So I think that's right. CB equals circular for I in range num spins. CB dot, and actually I actually want 1 num spins plus 1 because I want to start with 1. CB dot step forward step size, and then CB dot insert I. That seems right. And let's print cb.dict. That should be fine. And now to test this, we are going to step 3 times for insert and do 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's just try that 9. Spinlock step size equals 3. Num spins equals 9. So let's run this and see if I got any off by 1 errors, which I'm sure I did. Run day 17 spinlock.py. Zero, 0, 1, pause 1, 0, 2, 1, 0, 2, 3, 1, pause 2, 0, 2, 4, 3, 1, pause 2, 0, 5, 2, 4, 3, 1, pause 1, 0, 5, 2, 4, 3, 6, 1, pause equals 5, 0, 1, 2, 3, 4, 5, and 0, 5, 7, 2, 4, 3, 6, 1, pause 2, 0, 5, so 0, 9, wow, looks like we didn't get any off by 1 errors, so that's really nice. And so let's do a test and say and let me just add one more, which is because we want value after last value written. So I'll just call this value after self goes to none. And what I want is, let's just say index equals self.pos plus 1, mod len of self.buffer, return self.buffer index. So what I want to do is assert that Spinlock step size still equals 3 and num spins equals 2017, and then I have this value after equals, and then what did they tell me it should be? It should be 638. And let me test buffer equals that. Let me just do this so I can debug it. And assert that test. So if it goes wrong, this way I'll be able to debug it more easily. Absolute. So did I not return it? Return CB. That's fine. Wow, that worked. So test buffer dot buffer dot index of 2017 is 1530, and test buffer dot buffer 1531 is 638. Okay, so that looks pretty good. So let's put if name equals main. Say buffer equals Spinlock, step size equals, and what did this step size equal? 367, and I think that was a step size, and num spins equals 2017. And let's just make sure that that input is some number of steps for instance the first value. So buffer equals that, print buffer dot value after, and let's see if I got it right. Yesterday I did badly. This says 1487, so let's try 1487. That is the right answer. Cool. Okay. Spinlock does not short circuit. Instead, it gets more angry. It's spinning significantly faster. The good news is you've improved calculations. They indicate you didn't identify the value after 0. The bad news is that while you're determining this, Spinlock has just finished inserting its 50 millionth value. What is the value after 0 the moment 50 million is inserted? Is that 50 million? So this is again another one of these things where I think naively it's going to be Spinlock step size equals 367, num spins equals 2000, num spins equals 50 million, and okay, this is the sort of thing that I was worried about. If iMod 100,000 0, print I, because oh yeah, that's way too slow. The problem is that each of these inserts is super slow, right? So so how do I want to deal with that? I want to deal with that. We'll start with, let's just, again, we got to think about being clever here. So we can't spin this 50 million times. So we need to come up with something smarter. And something smarter could be okay, so one thing I notice obviously is that 0 is always in the first spot. So what we're really looking for is whatever's in the second spot. And so one thing we can do is we don't need to keep track of all these things. We actually just need to keep track of if we land on 0, then whatever's next goes in the second spot. Okay? So here's something that could be somewhat clever, and that is the following. So I'm going to call this second spot, and it is going to take a step size, which is an int, and a num spins, which is also an int, and it's going to return an int, and return the value in the second spot. And let's say that second spot, or let's say length equals 1 and second spot is none. Okay? And let's also just say that pause equals 0. Okay, so that's what we're going to start off with. And we actually don't care what's in the rest of the list. We only care because basically I'm doing a bunch of stuff over here, right? And then when I get to 5, 5 gets inserted here. So suddenly I'm keeping track of 5, and I can ignore the rest, just track the list. And then I insert 9, and then I'll keep track of that and ignore the list. So what I'm going to do is I'm going to say for I in range 1 up to num spins plus 1. Okay, so we're basically going to do a couple of things. If self.pause equals 0, then we're replacing the second, right? So replace second. I don't want to name the variable the same thing as second equals I. And then I also need to step forward, right? So step forward just means that, and this is not self.pause, it's just pause. So pause equals pause plus step size mod. So let's make sure I get the ordering right. So actually I want to step forward. So first we're going to, let's say, step forward. Pause equals pause plus step size mod mod length. And now if pause equals 0, second equals I, and then either way pause equals pause plus 1 mod length, right? So just comment this out so I can run it. So I think unused variable second. That's not true. Return second. So now if I run this, and what I want to do is I want to try those, second spots, step size equals 3, num spins equals 1, so that's 1, which is good. And then if I do it, num spins equal 2, it should go 2. 2. If I go numspins equals 3, it should still be 2, so that's wrong. If I do numspins equals 4, it's 4. If I do numspins equals 5, it's 5. Okay, so this is not right. So print and okay, so I need to do length plus equals 1. And so I think that might fix my problem. So let's try this again. And let me just do for ns in range 110, print ns second spot 3 ns. Okay, so this to the side so I can see it. So after 1 it's 1, and it goes 2, 2, 2, 5, 5, 5, and then 9. Good. So I think that's right. So now let's try and let me just I want to track progress. So if iMod 1 million equals 0, print I, and then print second spot step size equals 367, num spins equals, and it was 50 million. And let's make sure what is the value after 0. So yes. So that seems right. And let's just run this. 1, 2, 3, 4. Okay, so this is going pretty fast. It won't take too long to get to 50 million this way. So it'll take a little bit of time, but it's not terrible. So I think this is clever enough that it might work. And it says 25674,054. So let's try that. That is the right answer. Good. We were able to do that without too much problems. It's only 14 minutes till the next one, but I think I need to put my kid to bed, so we won't be doing that one right now. And just for fun, let's mypi day 17 Spinlock. Let's see if we can fix these. So this should be an int. It says no value expected. And it looks like these are my issues. Cool. So that worked. It wasn't too bad, and I feel better after yesterday because yesterday did not work. Find me on Twitter at Grus, and thanks for watching. This was much less painful than yesterday's. So